This is pre-AP pre-calculus. This is free response practice question number 24. No calculator can be used. The graph of the rational function h of x is pictured to the right, and we have an ordered pair, negative 1.50. That means that the y-intercept, scratch that, the x-intercept is negative 1.5, has a hole at 2, negative 7/5. I'm going to add these things to the picture. It's going to make this easier for me. So this x-intercept right here, that's negative 1.50. Let me make so I can see this a little bit better. Alrighty. And we have the coordinates of this hole. I'm just going to put right here, which is 2, negative 7/5. It's really nice to see stuff in the picture. It makes things a little more easy to figure out. State the domain and range. Well, the domain, those are all the x values that can be used for this function, and that's going to go from negative infinity to infinity, but we need to remove any of the restricted values. We have a restricted value right here at negative 3. So the domain goes from negative infinity to negative 3, hops over negative 3, and then it continues, and it's having a good old time until it gets to 2, and it's got to hop over 2. And then it goes from 2 to infinity because there's no more restricted values. Well, what about the range? Assume the range is also negative infinity to infinity. Then we have to strip off any y values that don't exist because the x values maybe took them away, or because we got horizontal asymptotes. Lots of different reasons here. So if we continue, we can follow this graph up till it gets to negative 2, and then it hops over negative 2, that horizontal asymptote. Continues to move up until we get to this hole, and it hops over it, then it continues up forever. That hole, the y value, is negative 7/5. We know that because the directions told us it was negative 7/5. So we got domain and range. We weren't asked to explain anything, and each of those would be worth 1 point as a free response question. Just going to label this as such. Each of those 1 point. Excellent. B, what factors is or are guaranteed to be in the denominator of the equation of h of x? Give a reason for your answer. So here's what I would do. Looking at this graph, I would add some things to it that I know are true. For example, there's a vertical asymptote at x equals negative 3. So because of that, I know that there must be a factor of x plus 3 in the denominator. There is a hole in the graph at x equals 2, so that must mean that there is a factor of x minus 2 in the numerator and denominator. That's a canceling factor. Since there's an x-intercept of negative 1.5, that must mean that there is a factor of 3x, no, yes, no. Let me write this out because I'm having trouble with it. If negative 1.5 is a factor, and if I add 1.5 to both sides, I mean, it could leave it like that, x plus 1.5, but generally, if we multiply each term here by 2, we would get 2x plus 3. Usually these factors are written as non-decimals. So you could either have an x plus 5 as a factor in the numerator, or you could have a 2x plus 3 as a factor in the numerator. Either one's acceptable. They're different things, of course, but as far as the factor is concerned, one of those two is a factor, either x plus 1.5 or 2x plus 3. And depending on which one it would affect the lead coefficient, which we won't get into that right here. What factors are guaranteed to be in the denominator? And then give a reason for your answer. I'm going to give the reason first. Factors in the denominator cause discontinuities. Factors in the denominator cause discontinuities. Therefore, I guess maybe we're not to a therefore yet. This graph of h of x's graph has discontinuities at x equals -3 and x equals 2. Now we're to the therefore. H of x has factors of x plus 3 and x minus 2 in the denominator. This is worth 2 points. Get 1 point for this, and we're going to get 1 point for saying both of these things. All right, C. For what values of x is h of x less than or equal to 0? Give a graphical reason for your answer. Well, let me give the graphical reason first. If h of x is less than or equal to 0, then the graph of h of x is on or below the x-axis. Therefore, h of x is less than or equal to 0 on the interval. What's below from -∞ to -3, though that is non-inclusive because none of those values touch the x-axis. And then in union with, it is on the x-axis at -1.5, that's inclusive, and it continues to be below until it gets to the hole, and it has to jump over the hole. Then it continues to be below forever because that arrow goes to the right and is below the x-axis. That is worth 2 points, 1 point for the reason, and 1 point for the interval. D, in standard form, find an equation for h of x. Give 2 graphical and algebraic connections that confirm your standard form equation is correct. Well, let's see, what can we do? Looking at this graph, I'm going to give you some things and we're going to write them down. For one, since there is a horizontal asymptote at x equals -2, that tells us the degree of the numerator and denominator are the same. Since the y-intercept is -1, that tells us that the ratio of the constants of the numerator and denominator have to be -1. There's a couple things. And let's write some of this stuff down. Okay, so here's how I would start with this. In this case, I'm actually going to write stuff down, then I'm going to probably give the reason. So h of x, I already did a lot of the work. We had a y-intercept of, or an x-intercept of negative 1.5, and I made a conjecture up here that one of our factors, then a numerator, is going to be 2x plus 3. We had a hole in the graph at x minus 2, so x minus 2 needs to be a factor on the top and the bottom. And then we had a discontinuity at x equals negative 3. That was a vertical asymptote, so in the denominator, we're going to need to have an x plus 3 in the denominator. Let's see how this shakes out. And you might recognize as we're doing this, if something doesn't exactly check out, and we're going to be able to fix that when it doesn't check out. So right now things are looking good. So the thing that we want to consider, so we know that the holes at vertical asymptotes and x-intercept are correct. What we don't know is the y-intercept correct? Is the horizontal asymptote going to be correct? If we multiply this out, we're going to get h of x equals, in the numerator, we're going to get 2x squared plus 3x minus 4x, that's a minus x. And then a 3 times a minus 2 is a negative 6. And the denominator, x times x is x squared. 3 times x is 3x. Negative 2x plus x is negative 2x. Add those, you get a plus x. And then we get this. But hopefully you can see right now this is not correct. It looks like it's close to being correct. But if you look at the graph, this is saying we would have a horizontal asymptote at y equals 2. But our graph has one at negative 2. This would show that we have a y-intercept of 1, negative 6 divided by negative 6. We have a y-intercept of negative 1. We need to change the signs of the top or the bottom in order to fix this. If we do that, I'm going to fix this in several places. I'm going to say we need to have a negative here, which means we need to have a negative here. If we distribute it, we're going to get h of x equals negative 2x squared plus x plus 6. Could you have multiplied it to the bottom instead of the top? Absolutely, top or bottom. Does that fix our y-intercept? It sure does, because now it's showing that it's going to be at negative 1. Does it fix our horizontal asymptote? It sure does, since the degree of the top and the bottom are the same. You divide the lead coefficients, which is negative 2. So let's read the question and make sure I answer the question. Is this or put it in standard form, which we have. Find the equation for h of x. Did it. Give two graphical and algebraic connections that confirm your standard form equation in context. Well, I'm just going to give you all of them and know that you need to have 2 of these. So you would get 1 point for getting this correct. So we could say something like in h of x, the ratio of the constants is 6 over negative 6, which is negative 1, which is the y-intercept. We just connected the graph, the y-intercept, to the equation, to the algebraic equation. So there's one thing you could say. We just need 2 of these, it says. We're going to list more than 2. H of x has a hole at x equals 2. I should say h of x graph. Let's do that. My apologies. H of x's graph, or the graph of h of x, has a hole at x equals 2, and h of x has x minus 2 as factors of the numerator and denominator. There's two reasons. We have to give at least 2. Well, it just says to give 2. I'm going to give you more to show you the options you have. Another thing that you could say, the graph of h of x has a horizontal asymptote at y equals negative 2, and h of x has the same degree in numerator and denominator with the ratio of lead coefficients coefficients. I'm such a bad speller. Still might be spelled wrong. Lead coefficients would be negative 2 over 1, which is negative 2. So what are we missing? I didn't address the vertical asymptote. I didn't address the x-intercept. The graph of h of x has a vertical asymptote at, where was it? X equals negative 3. And h of x has a non-canceling factor of x plus 3 in the denominator. Once again, I'm listing every reason that you could give. You only need 2 of these because it's what it says. It says give 2. And the last thing is the graph of h of x has a 0 at x equals negative 1/2. I think that's right. Looking at my picture. Yes. No. Negative 1.5. And h of x has a non-canceling factor of 3x plus 2. No, 2x plus 3. In the numerator. All right, so once again, you get 1 point for getting this equation in standard form, and then you get 2 points for listing any 2 of these reasons. I listed 5 reasons. You just need to list 2 of the 5, any 2 that you like, any 2 that float your boat, any 2 that tickles the inside of a dill pickle. All right, that concludes number 24. Thank you very much.